In this video, we will discuss how to subnet a Class B network address. Subnetting a Class B network is similar to subnetting a Class C address network, except we have both the third and fourth octets to work with. We don't need to work with the first two octets. 255.255.0.0 is the default subnet mask for a Class B network. This graph is a list of all the possible subnets for a Class B network. As you can see, we gain subnets and lose hosts as we borrow more bits from our octets. Compared to a Class C network address, there are quite a few more masks we can use. Subnetting a Class B network is no more difficult than subnetting a Class C, but it can get confusing if you don't pay attention to where the subnet bits and host bits are in the subnet mask. Practice is key to success. We'll start with the Class B subnet mask of 255.255.192 and 0, and figure out the subnet's broadcast address and valid host range. We will answer 6 questions. How many subnets does this mask provide? How many hosts per subnet does this mask provide? What is the magic number for this subnet? What are the valid subnets? What is the broadcast address for the subnet in question? What is the host range for each subnet? Remember, when subnetting in the third octet, you need to include the fourth octet in your calculations. For example, on the 255.255.192.0 mask, the subnetting will be done in the third octet. To create a valid subnet, you must add the fourth octet of all zeros and all ones for the network and broadcast address. For the first example, let's use the following IP address and subnet mask. Let's start by answering our first question. How many subnets does this mask provide? To calculate the number of subnets, we need to observe how many bits we have borrowed from our default Class B subnet mask. Then we will need to use the 2 to the n formula. The default subnet mask for a Class B network is 255.255.0 and 0. Translated in binary, we get all ones, all zeros, and all zeros. The subnet mask in this example is 255.255.192 and 0. Translated in binary, we get all ones, 1 followed by all zeros, and all zeros. As you can see, we are borrowing 2 bits from the original default Class B subnet mask. Using our 2 to the power of n formula, where n equals the number of borrowed bits, we get 2 to the power of 2. So our answer to question 1 is 2 to the power of 2 equals 4 subnets. Question 2 asks, how many hosts per subnet does this mask provide? To calculate the total number of hosts, we need to count how many host bits are available in our subnet mask. Then we need to apply the 2 to the power of n minus 2 formula, where n equals the number of available host bits. Remember that in this example, our subnet mask is 255.255.192 and 0, which translated into binary equals all ones, 1 followed by all zeros and all zeros. As you can see, we have 14 available host bits. Using our 2 to the power of n minus 2 formula, we get 2 to the power of 14 minus 2, so our answer for question 2 is 16,382 hosts per subnet. Question 3 asks, what is the magic number for this subnet? The magic number is crucial for determining each subnet address. We will further explain the importance of the magic number in a subsequent animation, but for now, just know that you need to understand how to calculate it. To calculate the magic number, we take 256 and subtract the number in our octet of concern. In this example, the number in our octet of concern is 192. So our answer to question 3 is 256 minus 192, which is 64. Question 4 asks, what are the available subnets? In order to understand this question, we will create a chart to help calculate all of our subnets. To determine the first subnet in this chart, we need to remember how to AND. If you cannot remember how to AND, please go back to that video lesson and do some practice. Take our given IP address and AND it with the default Class B subnet mask. You should get 162.118.0.0. Remember, if you forgot how to AND, please go back to the previous lesson and practice. To find our first host, we simply add 1 to the subnet address. We can't use 162.118.0 and 0 as our first host because it is reserved for the network or subnet ID. This means that our first host for the 162.118.0.0 subnet is 162.118.0.1. To find the last host, we come back to our magic number. Take the octet of concern, in this case the third octet, and add the magic number to it. Then subtract 1, so 0 plus 64 minus 1. For the last octet, we simply use the number 254. By now, we all know that the largest number in an octet is 255, but if you remember, we need to save the last host in any given subnet for the broadcast address. This is why our last host is 162.118.63.254. Our broadcast address can be expressed by simply adding 1 to the last octet of the last host address we just calculated. Our broadcast address is 162.118.63.255. To calculate our next subnet, we again get to use the magic number. Take the octet of concern from the previous subnet and add the magic number to it, 0 plus 64. We get 162.118.64 and 0. Now you can see why the magic number can be a useful tool. The first host for this subnet is 162.118.64.1. To find the last host on this subnet, we again take the octet of concern. Add the magic number to it and then subtract 1. 64 plus 64 minus 1 equals 127. Again, we will use 254 in the last octet so we can account for the broadcast address. Our last host is 162.118.64.254. Our broadcast is 162.118.127.255. Repeating this process for the last two subnets, we get all of our valid subnets are now in the chart. The answer to question 4 is 162.118.0.0, 162.118.64.0, 162.118.128.0, and 162.118.192.0. Question 5 asks, what is the broadcast address for the subnet in question? If we look at the 162.118.64.0 subnet from our chart, all the hosts are between 162.118.64.1 and 162.118.127.254. Our IP address for this problem is 162.118.67.3, and we can now see that it falls within this range. Based on our chart, this now tells us that the broadcast address and the answer to question 5 is 162.118.127.255. Question 6 asks, what is the host range of each subnet? If we look at our chart again, we can easily see the answer to this question. Our host ranges are, for the first subnet, 162.118.0.1 through 162.118.63.254. The second subnet, 162.118.64.1 through 162.118.127.254. The third subnet, 162.118.128.1 through 162.118.191.254. The fourth subnet, 162.118.192.1 through 162.118.255.254.